Hey, welcome to Build&AI. I'm Nia, your AI learning guide. Let's get into it.
Welcome to this explainer. Today, we're going to absolutely level up your React engineering skills. We're mastering the core pillars of robust component architecture. So if you've ever felt like your React components were getting, a little too rigid, or maybe just way too chaotic, well, you are in the exact right place. We're going to unpack exactly how typed props, internal state, and strict immutability all work together to create seamless, completely bug-free user interfaces. Let's get into it. Let's kick things off with the million-dollar question that sits right at the center of React architecture. Just how flexible can an interface really get without turning into an absolute tangled mess of duplicated code? You see, we need our components to adopt. They have to handle different data, different users, different situations, right? And we need to do all of that without writing the exact same logic over and over again or ending up with hopelessly rigid designs. To answer that, we're going to follow the evolutionary journey of a React component. We'll hit the reusability challenge, move on to typed props and composition, explore component memory and immutability, connect things up with typed events, and finally look into lifting state up. Section 1. The reusability challenge. Let's start with an immediate pain point that pretty much every developer faces at some point. Think about a really simple button in a management system. If that button always shows the exact same text and does just one single action, well, your code base is going to fill up fast with near duplicate copies the second a design requirement changes. But by letting the parent component dictate the data, stuff like text, icons, colors, you give your components the autonomy to thrive across countless screens. You're building a dynamic system here, not a static web page. You want a single component to be useful literally no matter the context. Section 2. Typed props and composition. Because honestly, flexibility without rules is just chaos, right? We need an explicit safety contract. So, props, short for properties. These are basically your component's API. Just like function parameters, the child component declares what it needs, and the parent fulfills those needs. And the absolute superpower here, it's unidirectional data flow. Information always travels top-down, from parent to child, never, ever the other way around. This forces predictability, it gets rid of that rigidness, and it massively encourages reuse, all because the component simply adapts to whatever valid props it happens to receive. Now, when you type those props with TypeScript interfaces, you aren't just writing code anymore. You are writing a strict legal contract. Let's say you've got a button component with a variant prop typed as a union type, so either primary or secondary. That guarantees that only those specific string values are allowed. If you try to pass tertiary, or if you totally forget a required label prop, TypeScript is going to reject it immediately. You're catching bugs at compile time, way before they ever reach the browser. And hey, props aren't just for basic strings or numbers. React has a really special built-in prop called children. Any content you nest between a component's opening and closing tags in your JSX, that automatically gets passed as this children prop. By typing this as react.react node, you create this amazing flexible zone. It can take text, other components, arrays, or even just null. This specific pattern is the absolute foundation of component composition. It allows you to build highly adaptable layouts and wrappers. It's basically the ultimate insert content here slot. Let's actually see this in action with a fully composable card. Step 1, establish the contract. We defined a required string title, our flexible children for the main content, and an optional footer. Step 2, we implement safe defaults inside the component. And step 3, concrete usage. Now we can use this card anywhere. The typing absolutely guarantees the title is always there, while the inner content and the footer stay completely flexible and totally safe. Section 3, component memory and immutability. We've mastered external data flowing in, so now let's talk about what happens when a component actually needs to remember things for itself. You see, a React component doesn't just store data in ordinary variables. Why? Because React ruthlessly reevaluates and completely wipes those ordinary variables on every single render. So state steps in as your secure vault. It's this private, living memory inside your functional component that actually survives those re-renders. It holds on to information like a counter's value or the text a user just typed. State is literally what allows your UI to react and update when users interact with it. And we have to draw a really hard line here between props and state. Props come from the outside. They are controlled by the parent and are entirely read-only to the child. State, on the other hand, lives entirely on the inside. It's owned by the component and it changes over time as interactions happen. Mixing these two up, like, say, trying to modify a prop directly inside a child, will completely break your component contract and lead to some incredibly unpredictable behavior. Just don't do it. We've all been there, right? Staring at a screen, yelling, "Why isn't the UI updating?" Well, usually it's a mutability issue. React only detects state changes by comparing references in memory. So if you have an array of tasks and you mutate it directly, like by using tasks.push to add a new task, the memory address hasn't actually changed. React just ignores you and the UI won't update. No way around it. The correct pattern is to create a brand new reference. You build an updated copy, usually using the spread syntax, and replace that old reference entirely. Section 4, typed events and interactions. Now that our component has a reliable, immutable memory, we need a way to actually connect it to user actions safely. In React, we handle interactions, clicks, keystrokes, you name it, using event handlers. But here's the catch. React doesn't use the browser's native DOM events directly. Instead, it uses its own standardized wrapper called synthetic event. Why bother doing that? Well, it ensures that events behave exactly the same across every single browser, smoothing over all those annoying cross-browser inconsistencies while still giving you access to specific subtypes, like mouse event or keyboard event. To keep our safety contract intact, we absolutely must strongly type these event handlers. If you've got an onChange event on an input, you type it as react.changeEvent at strong HTML input element. This ensures you never ever accidentally confuse a mouse event with a keyboard event. Leaving handlers untyped pretty much throws away all the architectural safety we've worked so hard to build up. Strongly type them and you slam the door shut on those silent, frustrating runtime errors. Section 5, lifting state up. For the climax of this explainer, we really need to look at the components ecosystem. What actually happens when multiple components need to talk to each other? Picture this. You have two sibling text input components, input A and input B, and they both need to display and modify the exact same text. If each input just holds its own local state via useState, they're going to drift out of sync super fast. They lose their single source of truth, and suddenly your interface is just a disjointed mess. The architectural fix for this is a classic pattern called lifting state up. Basically, you extract that shared state and its update logic, and you move it right up the component tree to the closest common ancestor of those siblings. So now the parent owns the state, and it passes the current value down to both children via props. This strictly preserves that unidirectional data flow we talked about earlier. But wait, how do the children update that state if they don't actually own it? They do it through the callback pattern. This creates this really beautiful triangular flow of data. The parent passes a callback function down as a prop. Then, when a user types into the child input, the child fires its onChange event, notifying the parent using that callback. The parent updates the shared state, and boom, React immediately propagates the brand new value back down to both children. Perfect synchronization, perfectly typed. When you bring all these Lego blocks together, you can seamlessly build incredibly complex UIs. Take a live validated registration form, for example. It relies entirely on these interconnected principles. The form manages its field state explicitly, updates it immutably so React detects every single keystroke, uses typed synthetic events for the inputs, and lifts state up to propagate valid changes back to the parent component. It's the whole shebang working in perfect harmony. All right, let's lock this in. Here are your key takeaways, kind of like a mental cheat sheet for mastering React architecture. Props flow parent to child, interfaces ensure safety, the children prop enables composition, state provides internal memory, immutability is absolutely required for re-renders, synthetic events standardize browser behaviors, and lifting state up is exactly how you sync siblings. When you strictly enforce typed props, immutable state, and one-way data flow, the ultimate payoff is just pure peace of mind. You get fewer bugs, hyper-efficient re-renders that only kick in when data actually changes, and a code editor that literally acts like your pair programmer, warning you about missing data long before a user ever sees your application in a browser. It is a total game changer. But as we wrap up, I want to leave you with a question to ponder. Lifting state up works wonderfully for closely related siblings. But what happens as your app's hierarchy grows and several distant branches need frequent access to the exact same data? When lifting state up no longer scales, what comes next? Well, that introduces the need for the context API or global state managers like Redux or Zustand. And the best part? Those tools build directly upon the exact same foundational principles we've just mastered today. Keep exploring, keep building, and I'll see you in the next explainer.
And that's a wrap for today. If this lesson was helpful, go ahead and hit that subscribe button so you never miss a new episode. We drop 3 new lessons every single week, all designed to help you learn, build, and launch with AI. Share this with someone who's on the same journey, and I will see you in the next one.